Hi guys, it's been a second, so I want to go ahead and just catch up with you. I know I missed a few of you guys in class today, so I'm sorry about that. I do want to talk about quick graphing though. That's kind of where we're heading with this whole thing. It's why we've been learning about parent function transformations, is so we can get a picture in our head faster than actually using t-charts. I want us to start being able to describe graphs, be able to describe what it is that you see, and I want you to be able to describe them via these transformations. So just a quick recap. We have learned about 4 parent functions so far. Tomorrow in class, we're going to get all of the actual DNA of the cubic function. As you guys explored him today, we're going to put it in physical writing and add to our parent function graphing chart that we started. So we've learned about linear lines, quadratics, cubics, and absolute value functions. The transformations, all transformations come to you in the format of y equals a times whatever the function, that's what this F stands for, whatever the function, linear, quadratic, cubic, absolute value, whatever the function, with x minus h and then your plus k. The descriptions. I have all the descriptions down. You guys had them before. I'd love for you guys to get them down again because the more times we write it and repeat it, the easier it's going to be for us to recall on them. So we're going to start talking about how if the a is greater than 1, we have vertical stretches. By what? By whatever the a is. If a is a fraction less than 1, so between 0 and 1, I have a vertical compression. This is where the graph gets fatter. We talked about metabolism speeding up. So my metabolism is 10 times faster, I would be nice and skinny. If my metabolism was 10 times slower, I would be 10 times wider. We want to talk about the h moving in the opposite direction of what we expect. So when h is positive, it moves to the left. When h is negative, it moves to the right. The next part that we're going to look at is what happens, which is what you guys did today with the cubics, is what the k does. The k is moving our y-intercept. So when k is positive, the y-intercept goes up. When k is negative, it goes down. Now the reason we don't completely refer to it every single time as our y-intercept is because when I start combining it with the h and the k, the y-intercept is not going to be on the y-axis anymore. So k has its own ability, but when there's no horizontal transformation, absolutely, k will be our y-intercept. And the last thing that we need to learn to talk about is when the a is negative. Not that it's a -4, just the fact that it's negative, not a -1/2, just that it's negative. It means I have a reflection over the x-axis, okay? So when we start to describe our graphs, you can tell me that a part of the graph has been shifted to the left, how many units, or it's gone up, how many units. The other side of that is we're going to use that to graph these 3 problems, okay? And we're going to use that to graph the absolute value function, the cubic function, and the square root function. Sorry, not square root, the quadratic function. So let's start with how we would quickly graph this, okay? So I'm looking at a vertical stretch, and I'm looking at a horizontal transformation and a vertical shift. I get that from the h and the k and my a. Those are all being listed on what it is I'm supposed to do. Now, I know in my head, this graph, because of the parent function, should look like a V. Its vertex would be at the origin. But now I'm going to transfer it. Without no t-chart whatsoever, I'm going to transfer this graph. This graph right here is going to go, this says to go right 3, and this says to go up 2. And what's moving right 3 and up 2? The vertex. The little v part is what's going to move. So I'm going to go from the origin, because that's where the parent function would be, right 3, up 2. And then I just know the graph is supposed to be skinnier than it was. And I'm serious, I don't want any specifics. I just want it skinnier than what it was. So there's the vertex, and there's a skinnier graph. And I'm done. That's it. You followed the transformations and you called it a day. Let's try that again. Let's try that with the cubic function. One where the vertex isn't so obvious. Here's your cubic function. The parent function travels through the origin. That's where the little S bend is kind of happening, is right there through the origin. So its x and y intercept was at 0, 0. If I look here, I have a transformation that tells me to go left 1, opposite sign, and then I have it tell me to go down 1. So I'm following the same sign of the K. Okay, so I was supposed to be at the origin. That's where the little curly thing was supposed to happen, is at the origin. Now what I'm going to do is I'm going to go left 1, and then I'm going to go down 1, and that's where the bend is going to happen. But it's cubic, and I know the cubic shape. So I'm going to come down, bend, and come up. And honestly, at this moment, that's all I care about, is can you sketch it with the transformations? We'll learn about the specifics later on when we're talking about other things or when it actually matters. Right now, it doesn't matter to me. I just want to know that you understand these commands and you know where to find them inside the equation. So now I have a quadratic whose parent function again is U-shaped and the vertex is at the origin. This, I have no horizontal transformation, so no horizontal. However, I have down 2. Plus I have this fraction. I have this 1/3. Now the 1/3 caused it to get really fat, okay? So I'm going to draw a nice fat parabola. That's what I'm going to do after I move its vertex, who was at the origin, but now got moved down 2 units. So I'm going to move it down 2 units, and then I'm going to slow him down. Nice and fat. Quick graphing. I just want us to get a picture down so we can learn to start to talk about it. I want us to be able to have a vocabulary so we can learn to describe things that we see. We're going to pick up with this tomorrow, play a little catch up, get some things cleaned up, ask any questions that you might have, and then we're going to work on a snow globe paper. Okay? Thank you very much. See you in class tomorrow.